Okay, so let me collect your homework assignments, and I will hand out homework number 6 for you, the description there.
Friday. Due Friday at 1:30. Hold on a second. That's weird. Does that mean we'll be working on it? Does that mean we don't have class on Friday?
It doesn't mean either of those things. It just means that you've got till 1:30 to turn it in. Does anybody else have homework assignment? Okay, so no class on Monday, remember. And I sent out the email yesterday that has guidance on how to begin on the project. If you're having a hard time knowing where to dive in, and even if you're not having a hard time, what I'd suggest is that you begin by doing these preliminary calculations. It's a list of questions like how many hours a day are you generating power, for the flow rate that I told you to do, 1 cubic meter per second generating, what volume is required. I asked these questions in a very particular order so that each question will be answered by the things you had to do before it. And then solving this manually in the order that I've constructed those questions, I think will help you to see what types of things need to be solved for in your spreadsheet. So please definitely go through those manual calculations, and I've got the answers, and I'm happy to verify that you've done it correctly if you've got questions. And so that's the project is due a week from tomorrow, which will be our last day of lecture. All right. We're going to start on chapter 6 today, which is very similar to chapter 5, which is very similar to chapter 4. It all sort of accumulates on top of itself. But before we get into that, any questions that you want to ask about the content from yesterday's class?
On that homework, I had a question that was with yesterday's.
Okay.
The IRR of the problem with the 24 months, or the $24 a month. Were you supposed to calculate that monthly or yearly?
I don't remember which problem you're talking about. Do you know the problem number?
49.
Problem 49?
B. Do both ways. Here's monthly, not that.
So they tell you the payment per month, right? $24 a month?
Mm-hmm.
And so you should solve that monthly.
Okay.
Yeah.
Good deal. Okay, it's all.
Okay, so in chapter 6, boy, it just seems like the projector gets more dim every day. I cleaned out the filter yesterday and it doesn't seem to be helping. Maybe it's an extra lamp that's needed. I'll crawl up there and get that next.
Great.
When we're comparing projects, there's a lot of different ways to find out which potential investment is going to be the best for us. We talked about how you can know if it's a yes or no on a certain project, either go or no go, by having a minimum acceptable rate of return and then calculating the present worth of the cash flow at the MAR, the future worth, the annual worth, and then the IRR method was a way for us to find out what the rate of return on the cash flow is under one assumption. And Josh, what's the assumption built into the IRR method?
That the inflation doesn't increase or decrease.
No, it's not that.
Oh,
Your rate of investing.
that's the same. Why?
At the rate of the IRR, right. Because in the IRR method, then remember, we're discounting everything at the rate that cash flow is being generated. So to overcome that weakness, we can calculate the external rate of return if you're not able to reinvest the cash at the internal rate of return. So those were some of the methods that we used to find out whether a project is profitable. And In Chapter 6, what we're going to be doing is comparing mutually exclusive alternatives. That means that there are alternatives that are mutually exclusive because maybe you only need one of the alternatives. So it could be a car that you're selecting between different vehicles and you only need one. Or it could be mutually exclusive because you have limited investment funds available. And so you want to make some sort of an improvement to a process or a business, but you can only afford one of those improvements. So, for example, let's say that you're going to be buying a used car and you're going to consider several of them, but you're only going to buy one, therefore it's mutually exclusive. So, different alternatives usually require different levels of capital, they last a different amount of time, and so it can be a challenge to compare them directly because of all of these dissimilarities. It's comparing apples and oranges when you've got a Toyota that may last 12 years and you're trying to compare it to a Hyundai that may only last 8 years. The Hyundai's cheaper, the Toyota lasts longer, they have different useful lives, they may have different expense diagrams where you can expect, because of maybe different warranty periods, to have lower out-of-pocket expenses for one vehicle versus the other. So we're going to consider all of those scenarios, how to handle different useful lives, and there's a variety of different things that you can do to compare alternatives when the useful lives have different periods. So one reason that we look at all of that is that you want to make the most out of your investments, or in other words, you want to at least make the minimum attractive rate of return for every dollar that's invested. So you don't want to spend any more than you have to on an investment, especially if it's not going to make the minimum rate of return. So sometimes there are different phases of projects, and different phases have different returns to them. And so what we're going to look at is how to know when to stop with the add-ons. You know, there are certain accessories or additions that can enhance productivity but may not incrementally pay for themselves. And an example of that is on computers. And there's lots of different features you can select on a computer. And when you go through the Dell website, you can choose which processor you want, which RAM, which hard drive, and maybe you can configure a computer that overall is going to be a profitable investment, but that doesn't mean that every single option that you selected is itself justified. You can break down the individual options and see if each one of the options is going to return at least the mark. So when we compare alternatives, the base alternative that everything is compared against is whatever requires the least investment capital. It's sort of like the cheap man's approach. Sometimes the base alternative is do nothing, make no investment. But more often, if you're comparing alternatives, that means that some sort of an investment is required. And so all the other alternatives are compared to whatever is cheapest. And we'll have a cash flow diagram for each of the alternatives, and we can set it up as a table where there will be the years, and each alternative in increasing cost is in the column next to it. Do nothing is usually the option that not only is the least costly, but it also isn't going to generate a cash flow that's above the minimum attractive rate of return. So do nothing isn't always the most attractive alternative. Even though it doesn't cost anything, it doesn't generate any positive cash flow. Now remember what we said about the internal rate of return and how the internal rate of return can't be negative. That is, if you have a positive cash flow and it's all taken to the present worth, then the internal rate of return is going to be positive. And so if you find the equivalent worth, meaning if you take all of the cash flows to the present or to the future or on an annual basis to compare them, and if you're discounting them at the minimum attractive rate of return and it's greater than 0, that means the investment is profitable. So this is just a review of what we've already known previously, is that it's worth doing a project if it's profitable, but then you have to sort them all in terms of which is the most profitable. If the equivalent worth is less than 0 when you're discounting it at the MAR, then it's better to do nothing than to select one of the alternatives, because that means that all of the alternatives are not profitable. So the equivalent worth methods include the present worth, future worth, annual worth, or you can calculate the internal or external rates of return. And the internal rate of return or external rate of return could be compared to your MAR, which is a minimum, or you use the MAR to discount future values to the present, or to compound values into the future, and so on. So there's a couple of different approaches that you've already learned on how to move money from time period to time period, and also to know whether or not a project is profitable. In cost alternative cases, those are where do nothing isn't an option, where it's not necessarily generating a revenue, it's just going to be expenses, but you're forced to choose one of the options anyway, even though it's not profitable. And so the logic of which one to select is a little bit differently. When we were talking in terms of investment alternatives, you're expecting a positive cash flow, and the investment is optional. You don't necessarily have to do it. But in the case of a cost alternative, you don't have the choice of do nothing. And so really the method here is to find out which of the alternatives is the least costly. And remember from the previous slide, what we said is the internal rate of return can only be calculated when there's a positive cash flow. And so in the case of a cost alternative, there isn't a positive cash flow. There are only going to be expenses there, and so you can't calculate an internal rate of return if there's no return. So here's an investment alternative illustration where up front you may have to make a $60,000 investment and get $22,000 a year, or comparing another alternative, and in this case they have the same lifespan of 4 years. You'd have a greater upfront investment, but you'd have a greater cash flow as well. And so which of these two options is better depends on the interest rate that you use as your minimum attractive rate of return. It may be that investment capital is very cheap for you to obtain, or it could be that it's very expensive and that you want to minimize the upfront expense. So this is an illustration of what investment alternative comparisons look like, and this is an example of what cost alternative comparisons look like. In this case, there is a upfront expenditure, but then there's never any revenue. It just continues to be costly. But in this case, you don't have the luxury of do nothing. You have to select something. So here's an illustration of what you do in order to find the present worth of all of these cash flows. In the case of alternative A, we already have negative $380,000 at the present, and then we would manually take each of the years back to the present, year 1, year 2, year 3, and we find the present worth of option A. At 10%, we're discounting option B as well, finding the present worth of it. And in this case, the present cost of option B is less. Even though there was more of an upfront cost, it was less costly over time. We couldn't calculate an internal rate of return here because there's no revenue. It's a net negative project. But in the case of a cost alternative, you have to pick something. You'd pick option B here. When you're comparing projects, there's a lot of different reasons that they cannot be comparable from an exact standpoint of interchangeability. It could be that one of the options has better performance than the other. It might not just be as easy as which is the most costly. You may have to consider the impact on productivity or fuel costs, how quickly the new piece of equipment can be used by the workers, how familiar they are with it. And this is a situation here, the operational performance. That's something that the company I worked for before I went to graduate school had a real struggle with. They didn't want to pay for Microsoft Excel. Back then, in I think it was 2001, it was pretty expensive to get a copy of Microsoft Office in a corporate environment. I think it was $500 or $600 for a full license of Microsoft Office. But they could get a competing project. It was called Corel for I think only $50. It was a tenth of the cost. And so they were looking at the upfront cost difference and seeing how cheap it was. But then that meant all the workers in the office had to learn Quattro Pro, which was their equivalent of Microsoft Excel. And so it took us a long time to get familiar with it. So it wasn't just as easy as a comparison of two completely interchangeable products. Our output capacity was lower because we weren't familiar with the software. Another factor that has to be considered is the quality factors. And you may remember that we did an in-class exercise earlier in the semester where you were making iPhone cases. You're trying to find out what the cost was going to be for businesses generating iPhone cases. And they had different, one of the differences between those two alternatives was how many cases per day could be made. And so rejection rate is when you have lower quality equipment that may cost less up front, then some of the product has to be scrapped because it's faulty. And then what we'll mostly focus on are the economic factors, and those are differences in the useful life that we can compare in a cash flow diagram, and the impact on annual expenses that we can quantify. And so 1 and 2 have to be considered sometimes in order to generate the cash flow diagram that we'll look at in point 3 there. So when we're comparing alternatives, one of the big rules is that the study period has to be appropriate for the decision being made. And what that means is that if a piece of equipment is going to last for a really long time, it wouldn't be appropriate for your comparison time frame to be a short period. If you're comparing two durable pieces of equipment that will each last 30 or 40 years, just comparing how they'll behave over a 2 or 3 year time span wouldn't be a reasonable way to compare them. And so you have to make sure that the useful life is kept in mind when the study period is being looked at. So what we're going to look at is one case where the study period is equal to the useful life and what to do if it's not equal to the useful life. So in the case of a piece of equipment that lasts for 30 years, it's best to do a comparison over the long scale to see how the two long-term alternatives will compare. But there are some ways that we can handle a short-term comparison for a piece of equipment that lasts for a really long time. We'll look at those methods today. So in case 1, which is where the study period is equal to the useful life, we can use the equivalent worth methods by just discounting everything to the present or finding the future worth or the annual worth of the alternatives. So you would use the MAR as the interest rate and find the equivalent worth, meaning one of those 3 things, at the interest rate. And then if it's an investment alternative, meaning that you expect it to generate a positive cash flow, then you just find out which has the highest value, which has the most present worth, and that's the project that you should select. In a cost alternative, then you would just select the one that's the least negative. It's not going to have a positive cash flow, but you can minimize your expenses. And this is all very you probably would have guessed these things if I hadn't told you anyway. If you had a bunch of alternatives that you took to the present, you'd pick the one that would either be the most positive or the least negative. That would be your natural reflex. And so the procedure, all 3 of these methods, regardless of whether you take the present worth, the annual worth, or future, you'll never get a different answer. They'll always identify the same alternative that's supposedly the best. So here's just an illustration of what that looks like. If we had these alternatives that all last 10 years, and they have the different capital investment and different annual cost savings. Let's look in Excel of how we could compare them using the equivalent worth method. And we're going to use all three of the methods just as a proof that you won't get a different answer depending on which method that you use. Okay, so we've got year. Actually, I should put a cell above that for MAR. And in this case, it's 10%. Year 0 through 10. Okay, and then we're going to have alternative A, alternative B, alternative C. Okay, so in the case of alternative A, it's 390 investment, and then it's going to give us $69,000 a year through this study period. Okay, 920,000, 167. All right, and negative 660. Okay, the first thing I'm going to do, even though this is identified as alternative B, A, B, and C, I'm going to reorder them because I like to have them in order of increasing initial upfront expense. So I'm still going to call them alternative A, B, and C, but my table is going to be in terms of increasing cost. All right. So we're going to find the present worth, the annual worth, and the future worth of all these. And so this first set is going to be the present value of all of them. Okay, so remember the way we do that is equals PV of after MAR. This is our N. Our future value, the negative. Okay. Actually, there's one more change I'm going to make. I'm also going to anchor just the A on the year. And does anybody, well, I'm going to dim that so you can see a little bit better. Why am I just anchoring the A rather than anchoring both of them? Yeah, so I can, when I drag down, it will find the different row, but I want to be able to drag it over sideways, and I don't want it changing its column. Okay, so that will allow me to use this way as well. I'm going to reformat that. Okay. No surprises yet. So then we find the present value of all of them, and then I'm going to find the sum. So this is the sum of the present worths. So alternative C is the best. It gives me the most cash flow at the present. So that's the best according to the present value. Let's see if it's the same answer if we do it according to the future value. So yesterday you learned how to handle N when we do future value calculations. What's the trick there? If I'm going to be doing equals FV, the rate is still going to be the MAR. N is what?
10 minus whatever row you're in, is that right?
Good, yep, that's right. So I'm going to say 10 minus whatever row I'm in, because I want N to be, N, and it's the future value, is how far away are you from the end. The end is year 10. So in year 0, we're 10 years away from the end. So 10 minus here, and again I'm going to just anchor only the column, not the row. It's not a payment, it's a present value, and this is the present value. I'm going to put the negative sign in because it always flips signs when it's doing these. So let's see if, according to the future value, it's still alternative C that looks the best once we sum everything up. I think there must be some sort of mistake. Oh, yeah, it's because it's looking at the present values and not at the original cash flow. All right, so I selected the wrong things. It should be looking over here at the original cash flow. This will be better. There we go. Okay, so alternative C is the best according to the future worth, equivalent worth method. Okay, and lastly, we can find on an annual basis, so the annual worth, we still got these same three alternatives. The annual worth, we're saying, equals PMT. What would be the payment associated with that? Here's our MAR that we're using. N is always going to be the same. This is a sort of a tricky thing since we've been used to having different N's for all of these. In these cases, every one of the, since we're spreading it out over 10 years, it's always going to be 10 as the N value. And it's all going to be present worths. So what this corresponds to right now is the upfront cost of $390,000. If you spread that out over 10 years, how much it would cost every year. So rather than paying it all at once, that's how much our payment would be if we spread that expense out over 10 years. All right. So then, as I drag down, the rest of these are the value of this, each one of them spread over 10 years. And so what we have to do is again sum it. And this is the annual worth of the profits. So, and again, I must have clicked on the wrong cell somewhere. We should get the same answer regardless. I may have to get back to you and see where my mistake is on that illustration because they will give you the same answer every time. What we had was alternative C was best, alternative C was best. It should be that alternative C is best. As you're working on the in-class exercise, I'll try and find where my mistake was. This is the present worth method for all of those. And these are the same as the answers that we've just found. Present worth. The real heart of today's lecture is figuring out methods to deal with when the useful lives have a different length. there's something called the repeatability assumption, and this is something that you should write in the margins that's really important. Make note of the repeatability assumption, because the repeatability assumption is this way that we have of overcoming the fact that useful lives are sometimes different. And what we assume in the repeatability assumption is that something we can buy now for a certain price and then generates a certain cash flow, we could buy the same thing in the future for the same price, and it's going to generate the same cash flow. Essentially what we do is we just repeat the entire cash flow diagram another time through a whole cycle. And so sometimes that's applicable, sometimes it's not, because of increasing costs of materials and decreasing profitability over time. But it's one way for us to overcome the difficulty that there can be different useful lives when we're comparing alternatives. So sometimes the repeatability assumption really isn't valid, and then in those cases we have to compare the alternatives really on the basis of having different lifespans, where the lifespan may be greater than or less than the project. So here's an illustration of how we would apply the repeatability assumption. Let's say that the cash flow diagram that's illustrated here is that equipment A lasts for 4 years. It costs $3,500 up front, and then each of the 4 years it generates $1,255. You can see here's one cycle of it. At the end of the year 4, you buy another one for the same cost, and you run the cycle a second time, buy another one, run the cycle a third time. And the reason why we were doing that is we're comparing one piece of equipment that lasts for 4 years with a piece of equipment that lasts 6 years. And so we have to find out, like, how many cycles do we run of A in order to have the same study period as equipment B. So running 3 cycles of equipment A and 2 cycles of equipment B will give us the same 12-year study period. And so this is one way of using the repeatability assumption to now have the same length of time over which to compare the two items. Okay? When you can't do that, if it's the case that the repeatability assumption doesn't apply, then one way to overcome the difference is to just assume that you're going to rent something at the end of the useful life of the shorter equipment. So maybe contract, leasing for the remainder of the study period. So let's look back at A versus B. If we're going to assume that you couldn't compare them by just repeating, then option A is 4 years, and we're comparing it to B, which is 6 years. So what we would do is we'd say extend option A, and then you're just going to rent for the last 2 years. Or lease, and then now you have them both 6 years long. That is one approach, if it's a cost alternative. Another way of doing it is to just shorten how long B is. So in the first point, what we said is we would lengthen A with leasing or contract. Another way is just to have B only run for 4 years, and then you would sell it for a salvage value. So if I was comparing a Toyota and a Hyundai, at the end of year 8, when I just drive the Hyundai into the Ohio River, then I'd sell the Toyota. And so now I can compare them for the same useful life. All right? So in that same analogy for part 1, after the Hyundai died, then I'd lease a Hyundai for the remaining 4 years. And so the way that I compare the two is my first 8 years of buying it, the next 4 years of leasing it, and then compare it to the 12-year lifespan of owning a Toyota. Remember that an investment alternative is we expect that there's going to be a positive cash flow, and that that gives us the flexibility to try one other method for comparing alternatives, and that is that you've got some cash flow that's been generated. Let's say, in this case, it only goes for 4 years. 1, 2, 3, 4. 1, 2, 3, 4. 5, 6. Okay. Another way to compare the two when they don't have the same useful life is to say, I'm going to take all of this, convert everything to amounts in year 4, and then invest that money for years 5 and 6. 5, 6. And so then you would convert it all to an amount at year 6, and then you could convert this all to an amount at year 6, and then you'd find out which is the greater. And so if it's generating cash flow, you just run the cycle A, and then consider the project finished, and invest the money in something else. And then that allows you to compare alternatives without any of the restrictions from the previous methods. Another option is to just replace the initial investment with another asset, meaning just buy a different piece of equipment, and it may generate different cash flows, but find something that lasts for 4 years and then replace it with something completely different that'll last for 2 years. And so maybe my plan when I'm comparing Toyota and Hyundai is buy the Hyundai for 8 years and then buy a used Hyundai for another 4 years. And so then I have a total 12-year project period. So there may actually be one piece of equipment and one alternative, and then 2 pieces of equipment that end up giving you the same useful life in the other alternative. Okay, if the study period is less than the useful life, then the most common technique is to just figure out the salvage value of the equipment or the market value and sell it at the end. And so all of these techniques, the point was to try and compare projects that may have different useful lives and find out which of them generates the best return for us. And so, let's see, I don't think I include these examples in the Well, let's look at a couple of cash flow diagrams just before I give you the in-class exercise. I want to make sure that you've got plenty of time for that one. Okay, so in this case, there's a cash flow diagram, option A, that's only 4 years, option B is 6 years. And so we want to find a common analysis standpoint, same length of time. And so what we can do is, this is the case where you want to invest all of the earnings by finding the future worth of all of the revenue in year 4 and then compounding it from year 4 to year 6. And so what this solution is showing is to compare the 2 alternatives without having to do the repeatability assumption. You just take the initial expense of $3,500 to the future from the present. And so that is compounding at 4 years at 10%. So you've moved it to year 4. And then you've also moved all of the annual revenues to the future at 10% for 4 years. And so that takes both the initial expense and the revenue to year 4. And then you compound it from year 4 to year 6 at 10% for 2 years. And so that gives you the total future worth of one alternative. And then it's doing the same thing in option B. It's moving the $5,000 to year 6, and then also moving those annual revenues all the way to year 6. So this is an illustration of how, if the repeatability assumption doesn't apply, you can move money into a comparable basis. And so let's make a list of all of the techniques that have been identified today for comparing alternatives. So, what are the techniques for comparing alternatives?
Costs. Equivalent work.
there's the equivalent worth. And so that means the present value, future value, annual worth. And so what we do with that is you find which alternative is most positive. There's some investment alternatives that generate revenue, and there are cost alternatives that don't generate revenue. But in either case, the principle is just find the most positive, and that's the alternative that you should choose.
Is the future value and the future worth the same thing?
Yes.
Oh.
It's just a function in Excel. It's called PV and FV, but in the book it says like PW for present worth instead of present value.
Okay.
So when I say PV, I mean the same thing as PW. Future worth is the same as future value. Annual worth, the Excel function there is PMT, payment. All right. So that's one method. Now, in order to do this, they have to have the same useful life, or what do we do if they don't have the same useful life?
It's called factor of
Okay, we can do the repeatability. Technique, where we're finding the least common factor and repeating the cash flow over again. Maybe it's not repeatable. And so if it's not repeatable, then not repeatable. Okay, one way is to find the salvage or market value. And what that does is it truncates the longer of the two options. So it's like saying one of them lasted 8 years, one lasted 12. You're going to take the one that lasted 12 years and make it as though it lasts 8. So find the salvage / market value. With that, I'm going to be sell the Toyota. In year 8 to compare to the Hyundai. Okay, what's another thing we can do if it's not repeatable? Charles, do you remember a different approach?
Can you bring it, bring the cost down to the lower year, to the one that has like the last year?
Okay, so there's two, one that's the longer number of years, one that's shorter. In this one, we're taking the one that's longer and we're making it a shorter cash flow.
So take one that's shorter.
Okay, taking it shorter and making it longer. And there are two ways that we can do that. You remember what are the two ways that we can make the shorter cash flow longer?
You convert to the future from the smaller amount, then you convert it again to.
Okay, so you're talking about the one that's illustrated here, you're investing. And so one option is invest the cash flow of the shorter alternative for the rest of the study. All right.
Cost alternative?
What's that?
Cost alternative?
Well, cost alternative is when we're saying there's a cash flow that doesn't generate revenue. And so there can be cost alternatives. It's sort of like a type of cash flow diagram. It's not necessarily a technique. Yeah. There's one more way that we can, so in this investment we're making, just as a note, make the short alternative longer. Where here we were making the long option short. There's one more way that we can make the short option longer. It's not investing the cash flow. Evan, do you remember what that last method is? No? You've got it there in the notes.
The one where you contract out the remaining years?
Absolutely, yeah. Contract / lease equipment or remainder. Okay, so in this option, I rent a car for years 8 through 12 for the Hyundai option. So these are all ways that we can make sure that we follow that fundamental principle of engineering economy is compare things on a like basis. You can't compare alternatives in a reasonable way if they're not on a like basis. All right. Well, let me give you this in-class exercise. What you've got is just two mutually exclusive alternatives. And you should complete them assuming the repeatability assumption does apply at first. And then in part B, I tell you that the repeatability assumption doesn't apply, and I tell you how to handle that. And part C is you're verifying it with Excel. So the computer cart is open. Feel free to grab one of those tablets and fire it up.
They just take so long to load and won't wait.
Yeah, I should tell you that at the beginning of class, huh? So it can be all fully loaded by the time you're ready. Okay, so in the annual worth method, remember we already found that option C was best for the present and future value. For an annual value, these are already annual values here. And so all I needed to do was find the annual worth of the investment and then combine that with the annual revenues. So in the annual worth method, you're just finding out, what is the revenue each year. And so it is the annual worth of the expense plus how much you're making each year. Every year we're making $69,000 for this option, making $133,500, $167,000. And so here's the annual worth of the expense. Here's the annual worth of the revenue, and you combine the two, and alternative C is best. So I was overthinking it, or I guess underthinking it, depending on how you'd say it. But that's the correct way to find the annual worth of that cash flow. I probably would have got it right doing it the hand way.
Is there a reason you did alternative A than C than D?
Yes, it was because of the increasing cost. Because this was 39, 66, and 92. I just put them in order. Yeah, when we get to another chapter, it'll be important for them to be in order because we're going to be doing incremental analysis, and so that's just a habit there. You wouldn't have to do it in this method for it to get the right answer, but did anyway.